Hi everyone, this is going to be a part of a small series of screencasts that will help you with your third and final assignment for this year. Now the third assignment that we have you doing this year is measuring the performance of a water pump and making an interface so that we'll be able to see that. And basically to do that we've got to measure two performance aspects of a pump, and that's the flow rate, so how much fluid is actually moving through the system, and how much pressure loss is over the system. So the pressure loss over a system is a measurement of the system head, so that's the sum of all the restrictions. So basically how these two values interact is the higher a system head is, so the higher the pressure loss over a system, the harder it is to move fluid through it. Okay, so if we make a plot of flow rate versus system head, then we'll actually find out how well our pump performs over a series of different environments. And so if we were to design a specific pipe network, we'd be able to determine the system head based off fluid dynamics theory, and then you use a pump performance curve to test whether or not our pump is going to be sufficient. Okay, so we have an experimental setup to do this, and all that is basically two sensors that hook into an Arduino, and we're going to plug the Arduino into a computer, and we're going to use the computer to plot the actual values. Alright, so the two sensors that we have, one is a flow meter, and that guy measures the flow rate that goes through it, and the other is a pressure differential sensor, okay, and that will give us our system head. Now they both hook into something that's called an Arduino, which is a little prototyping board, this little microcontroller, and basically it has a lot of pins on it, and we can give those pins digital and analog signals that are the measurements of what we want to measure. Okay, so what I'm going to do in this video is sort of explain how the code on the Arduino works. So I've already written this, and it's going to be provided for you, so you don't have to change it, but I'll go through and explain what's going on. Okay, so the code that is working on the Arduino looks like what we have on the screen. So this is the Arduino interface. It's a different programming language than MATLAB, so this language is based off C or C++, and so it'll look somewhat familiar, but it's a little bit different. So I'm going to go through this code in a second, but I just want to explain how our two different sensors work first. So I'll start with our pressure differential sensor. Now what our pressure differential sensor does is it takes an input voltage, so we give it some initial voltage. In this case we're going to give it 5 volts, and depending on the pressure difference on the two inlet ports on the differential sensor, it will output a scaled voltage. So if we give it 5 volts, it will be somewhere between, it will give a return voltage somewhere between 0 and 5 volts, depending on the pressure difference. Okay, so that's how we're going to measure that one. This is typically considered an analog voltage signal, and fairly easy to understand. Our second sensor is our flow meter, and what our flow meter does is it's not a just a straight voltage that we can read to determine how high our flow rate is. What it does is it accepts an input voltage, and when there's water flowing through it, there's a little water wheel that's spinning around, and each time it spins around it makes a little pulse. Okay, so each time we have a pulse, we know that approximately a certain amount of fluid has flowed through our device. So what we have to do is define a time period, and we count the amount of pulses over that time period. So in our case we've got a 1 second time period. So we count how many times we get a pulse over that period, and then we can multiply that number by some scaling factors to determine our flow rate. Okay, so this is usually called a pulse width modulated signal, so PWM, and those two sort of represent two very common types of signals that you'll encounter. So let's actually go through some of this code. Now, like I said, it should look familiar because a lot of programming sort of has a lot of different programming languages have a lot of common features. Like I said before, this is based off C. So let's look through it. In this first section here, which I've highlighted, we've got some initial variables that I've set up. So, which is the flow frequency, which is counting, which we're going to use to count the amount of pulses. We've got how many liters per hour. So liters per hour is the measurement that we're going to make for our flow rate. I've got a variable that stores which pin the flow meter is connected to. So there's heaps of pins that are on an Arduino, and we need to specify which one. And I've got these two variables here, current time and C loop time. So this is how we're going to actually time something to happen over 1 second. All right, the second little bracket of variables here are for the pressure differential sensor. So the input voltage is given to the Arduino as a integer value between 0 and 1023. Okay, so we've got 1024 different values it can take. This is 10 bits of precision, and yeah, so that's how we'll read our voltage. We get it as an integer value. I convert it to a floating point value, so it's going to be the actual voltage that we get. So in our case, it's going to be between 0 and 5 volts. And I've got another floating point number to store the actual pressure differential, so how much of a pressure drop is between the two ports. Okay, so that's just a bit of setup of variables, and I'll go into some of these functions that are going to happen. So with an Arduino, basically every program is going to have two functions. It's going to have at least two functions, sorry. It's going to have this void setup and void loop. Now what void means in this context is basically this function doesn't return any values. So setup doesn't return anything, and neither does loop. Now what the Arduino does is it runs setup once, so it goes through this process once, and after that happens, it continuously goes through this loop. So it'll go through it once. When it gets to the end, it'll go back to the start and do it again. Okay, so that's what those two functions do. So I'm going to go through sequentially what happens in this program to explain what the basic process is. So we'll start with setup. All right, so the first line of code that I have is this serial.begin. Actually, before I say that, comments in this language start with a double // So any line that has a double / is just a comment. Okay. So the first line is I open a serial, or I begin serial communications rather. Now that's how we're going to transfer this information to a computer. Okay, it's via serial. And basically we just need to start serial communications before we can actually send anything through. Okay, the next little block of code that I have here is to set up some stuff for the flow rate sensor. So basically we let the pin know that there's going to be input on that pin. So we're going to be reading the values from that pin, and the pin that we have is this flow meter, and that's the pin number that we defined at the start of our code. Okay. Our second little line in this block is this attach interrupt function. Okay. And basically what we want to do is every time a pulse happens, we want to interrupt the program and count that pulse. Okay, so we attach this interrupt, and this flow is the function that is going to be run whenever we get a interrupt. Okay, so all this flow function does, looking at it up here, is it increases the value of this flow frequency by 1. So if it was 0, this line of code would increase it to a 1. If it was a 1, go to 2, so on and so forth, right? So each time we get a pulse, we just increase flow frequency by 1. Okay, so we can see how we're going to be counting those pulses. And let's find a little input here that says rising. Just means that we're only going to count the rising components of these pulses, so we're not counting it twice or anything like that. Now, this just sets the interrupt up. We haven't enabled it yet, so this next line here enables this interrupt, and the next two lines start counting. So we want to count the amount of pulses over a second, and then work out how much fluid flowed through in that time. Okay, so millis gives you the amount of milliseconds it has been since the Arduino started. That gets stored in current time, and then we have this loop time is equal to current time. All right. Now that setup has been run, we can now go into our loop. So the first line that I have in this loop is setting the current time to milliseconds. So this is always going to be the current time, but we don't update C loop time this time, okay? So we have an if statement, and that says if the current time is greater than or equal to the C loop time plus 1,000, so plus 1,000 will be plus 1 second. If that is true, so basically what this is doing is if 1 second has elapsed, then go through and execute this code inside the if statement. And that's how that works. So if 1 second has elapsed, we read update C loop time to the current time. We disable the interrupt. So the CLI function here will disable the interrupt, so we stop counting pulses while this is happening. We first get the value for the pressure differential, so we read what voltage is on the second analog pin, so that gives us an integer value. Then we convert that integer value to a measured voltage, so we take the sensor value, we multiply it by 5 divided by 1023, which gives us the voltage in actual volts. This next line here applies a conversion between voltage to actual kilopascals, so an actual pressure difference. So we've got whatever the voltage is divided by 5, so we normalize the voltage. We offset it by a little bit, and then we divide it by this number. Now, these two numbers here are determined by myself, and basically they, when there's no pressure differential between them, then this sets the dP value to be 0. So this just shifts it a little bit, and this is the slope. Okay, so once I've got a pressure differential, I'll print that to the serial so that our computer can read it, and then I'll continue on. The next bit converts our pulses into a flow rate. So to get liters per hour, we take how many pulses we have, we multiply it by 60 and divide it by 5.5. Okay, so these values, this 5.5 value is from the manufacturer, and you can see here, this is the equation. So pulse frequency in hertz is equal to 5.5Q, where Q is the flow rate in liters per hour. And there's apparently a 3% range that this value can take. So I use that equation to find out how many liters per hour I have, and then I reset the amount of pulses. So I set them to 0, and then I print those values to my serial, and I re-enable my interrupt. And that's all this code does, okay? So fairly basic. I'm going to stop the video here, and I'll continue on in the next one.